We're looking at homework from section 6.3. This is question number 10. A researcher wishes to estimate with 99% confidence the population proportion of adults who think Congress is doing a good or excellent job. Her estimate must be accurate within 2% of the true proportion. We have three questions here. A, no preliminary estimate is available. Find the minimum sample size needed. B, find the minimum sample size needed using a prior study that found that 44% of the respondents say they think Congress is doing a good or excellent job. And then C, compare the results from part A and B. First, we must recall the minimum sample size formula. The minimum sample size formula for a confidence level C and a fixed margin of error E is given by N equals P hat Q hat times ZC over E squared. If you don't have preliminary estimates, then the values you're going to use are P hat equals Q hat equals 0.5. So that's what we're asked in part A with no preliminary estimate available. So let's go ahead and insert these values. For part A, N equals P hat Q hat times ZC over E squared. Because we have no preliminary estimate, the P hat and the Q hat are both 0.5. So we get 0.5 times 0.5 times 2.75 over 0.02. The 2.575 comes from the table of values that I gave you that showed that a 99% level of confidence has an associated z-score of 2.575, and the 0.02 is 2% converted to decimal form. When we simplify the fraction, we end up with 0.5 times 0.5 times 128.75 squared. And when we multiply that 128.75 squared, we get 16,576.5625. Multiplying all these numbers together, we get 4,144.140625. Rounded to the next highest number is 4145. Remember, minimum sample size, we always round up, no matter what traditional rounding rules say. So for part A, the minimum sample size is 4,145. In part B, we do have preliminary estimates. The preliminary estimate is that 44%, 0.44, is P hat. So if P hat is 0.44, then Q hat is 0.56. We still have the 2.575 over 0.02. So the only thing that's changed in part B is the values for P hat and Q hat. We simplify that fraction, and we end up with 0.44 times 0.56 times 128.75 squared. When we square that, we get the 16,576.5625, and then when we multiply all the numbers together, we end up with 4084.465. Rounded up is 4,085. So that's our minimum sample size when we have that prior estimate available. Now we're supposed to compare the results. Hopefully you realize that's the way that it works, that when you don't have a preliminary estimate, that gives us the largest possible sample size needed, and that once we have a preliminary estimate, then the sample size will shrink. But having no preliminary estimate gives us the maximum sample size. So the correct answer here is choice B. Having an estimate of the population proportion reduces the minimum sample size needed. And that's your answer.